Although it's been 46 years since the first moon landing, the moon remains a mystery. When we look at the moon at night, we feel something familiar, but also somehow something strange. This moon is actually too big for the Earth. If you look at the other planets, only much larger planets have such big moons. The moon was formed by a cosmic catastrophe. That's the official theory. 4 billion years ago, a Mars-sized planetoid collided with early Earth. The debris from this collision condensed and then became the moon. The moon is 384,400 kilometers from Earth. This seemingly random distance is crucial, especially for a solar eclipse. After forming, the moon was 20 times closer to Earth than now. The Earth's tides are owed to the gravitational force of the moon. 4 billion years ago, the moon was only about 25,000 kilometers away from the Earth. Think about how heavy life would have been impossible for us humans then. The moon's close proximity made its forces stronger, causing much more intense tides. A day was just 6 hours long because Earth spun much faster on its axis. The Earth-Moon distance grew until a day became 24 hours. The distance continues to increase. Someday the moon will nearly leave Earth, making days 27 times longer than now. The moon rotates once on its axis for each orbit around Earth. That's why we always see only one side of the moon from Earth. People often wonder what's on the far side of the moon. Of course, lunar probes have already been sent to that unseen side of the moon. Interestingly, that side has far fewer impact craters than the one we know. They've found so-called stretch marks there, which are still relatively young, as if the moon had been split in two. What might have caused these young cracks? The moon has a diameter of about 3,476 kilometers. That's a quarter of the Earth's diameter. The Earth-Moon distance is roughly 10 times Earth's equator. By the way, the distance to the Sun is 400 times greater. If the Sun were an orange, Earth would be the size of a rice grain. At this scale, the Sun and Earth would be 10 meters apart. Just try to imagine this incredible distance at that scale, and keep in mind that this is still nowhere near the size of our solar system. Our galaxy has tens of billions, and there are also tens of billions of galaxies in the universe. Australian scientists found there are 70 sextillion stars in the universe, a 7 followed by 22 zeros. If true, there are more stars in the universe than grains of sand on Earth. Back to the solar eclipse. For a solar eclipse, the size of the Earth, the Moon, and the Sun is also crucial. So when the Sun, the Earth, and the Moon are lined up during a solar eclipse, it's by no means a given that the Moon would cover the Sun exactly. These three celestial bodies must have these exact sizes and distances for this to happen. So the circumstances for such a spectacle are limited in time. If the moon was slightly closer to Earth as it was in the past, it would cover not only the Sun but also its outer atmosphere. If the moon moves farther from Earth, a solar eclipse would still show a ring of the Sun around the moon. So, the solar eclipse is a very significant cosmic event. Earth is 4 billion years old, and we happen to live when this phenomenon is possible. Jupiter has 67 moons, but none can cause a total solar eclipse there. I wonder what symbolic meaning the solar eclipse could have for us humans. For example, it's said that in the past, a war battle would abruptly stop during a solar eclipse. Or imagine the people who didn't know what was happening in the sky. What kind of fear must that have been? The solar eclipse might always remind us how privileged we are and how grateful we should be. About this state of the Earth, and generally about the perfect conditions of the three celestial bodies, Earth, Sun, and Moon, so that life on Earth is possible. This cosmic coincidence, as astronomers call it, is something that should make us thoughtful and fascinate us. But back to the perfectly tuned three celestial bodies. The Sun's diameter is nearly 400 times that of the Moon. At the same time, the distance from Earth to the Sun is also about 400 times greater than the distance from Earth to the Moon. It's remarkable that 400 appears in both cases. The ratio of the Earth-Sun distance to the Earth-Moon distance and the Sun's diameter to the Moon's diameter is 400. That's why, from Earth, the Sun appears to be the same size as the Moon. The Sun is 400 times larger and also 400 times farther from Earth than the Moon. That's why, and only because of these proportions, the Moon can cover the Sun exactly when it's between the Earth and the Sun. With this covering logic, you can calculate the diameter of the Moon yourself. You take a spherical object and try to cover the Moon exactly for your eyes with it. The radius of this spherical object divided by the distance from your eyes to this object is equal to the radius of the covered object, that is, the Moon, divided by the distance from your eyes to the Moon. Knowing the distance from Earth to the Moon lets you calculate its diameter. A pea with a diameter of 6 cm, for example, covers the full Moon if you hold it exactly 66 cm away from your eye. From this, you simply get the following equation, which you just have to solve for x. These three bodies are in this beautiful proportion to each other. Imagine your eye as the Earth, the pea as the Moon, and the real Moon as the Sun. And they say you just happen to catch it by chance. Despite the different sizes of these objects, there is a distance between the three so that the pea covers the Moon. How unlikely is this?